So a little help with what testing looks like for this standard. Going back to the Achieved Merit Excellence, for Achieved, a sample of expected cases. So that's not very comprehensive and not very thorough testing. Merit is a sample of expected and relevant boundary cases. We'll talk about boundary in a second. And then excellence is comprehensive. So to illustrate this, I've got a little game running here. This is a reaction time. The idea is when the little guy appears, I have to hit the space bar as quickly as I can, and it tells me how long it took me to hit the space bar, and it goes on forever. This is all fine, but you might notice it's always exactly 2 seconds before this guy appears. So I changed it to make it a random period of time before he appears. Otherwise, you can just kind of spam it really quickly like that. And so let's go and have a look at that program and see the change I made. I made it so it was not just 2 seconds, it was always a random number. And in the testing document, what that looks like is I wanted to do a random delay before the reaction character is shown. That's the component I'm testing. And I've made it very clear exactly which code it is I added to the program that I'm actually testing. In this case, it was very minimal. It was only a couple of lines. In other cases, it will be more, maybe. And how did I test it? I tested it by playing it. I played 20 rounds, and exactly what am I trying to look for? I'm checking the range of delays is random. So I'm being really clear about what I'm checking for and how I'm checking it, and what the expected result is. And it worked as expected. I did notice that it was kind of annoying because sometimes you got a delay that was like 0.1 second, and that affected the gameplay adversely. So I tweaked it so it was always between 1 and 4 seconds, and then rechecked, and it worked as expected. Okay. Then slightly more. So actually, just to recap on this is fairly comprehensive testing. I've added a very minor feature, and I've comprehensively checked, and I'm being very clear that that works perfectly. That's comprehensive testing, lots and lots of little tests like that. A little bit time consuming to do, but if you do it as you go along, it's not too bad. Now I'm going to look at a slightly more complex feature. I wanted to have it so that I had 10 rounds in my game. So I've added a constant at the top. I've added a round counter variable. I've got some logic in terms of the round counter, and displaying at the end I display an average time calculated from that, and I've got some other logic in here as well about the round counter. So easiest thing to do is look at the testing of this. So I've done a whole new test. Instead of endless mode, program changed to 10 rounds only. And this is a much more complicated piece of testing because there's quite a lot going on. In fact, I've got the code all scattered through the program. Which is not great programming practice. I could do better, but that would be another day. So I've tried to snip in all of the little bits of code. This whole section here has got so much in it, so I'll put that as it is. And these other places I've highlighted what are the bits that I've changed. And now this is the bit where I'm really looking for the merit and excellence, is this comprehensive and boundary checks. So things like, firstly, checking there's a round counter being displayed. Is that displaying correctly? Round 1, round 2, etc. Yep, and that worked. Checking that the user input has no effect after the game finishes. So you can't keep pressing the spam button and it increases the round counter, which would probably decrease your average time, that kind of thing. A sanity check. This is quite important. So I get a final average score. If I've been getting 0.3s and 0.4s as my reaction time, and suddenly I'll get a 0.2 for my average time, that does not pass the sanity check. This is super important, this one. Exactly 10 rounds, not 9, not 11. This is the boundary, the out by 1 errors that are really common in programming. If you trying to count down to 0 and you end up at 1, or you count up to 10 and you don't get to 10. And in fact, that's exactly what the problem is here. This round counter less than 10, this gave me 9 rounds. So I needed to make it less than or equal to 10. That's a spoiler alert. We'll talk about that in a second. And then you've got to also think a little bit outside the square. You've got to go outside your happy path. You've got 10 rounds. That's working just perfectly. What about 5 rounds? What about 1 round? What about 100 rounds? Well, maybe not 100 rounds. You're not going to test that. But just thinking, what could you possibly do to break it? And a little bit of creativity is sometimes required there. You've written the program, you know exactly how it's supposed to work. Think about what someone who didn't know how it's supposed to work would use it, or someone who was actively trying to break it or cheat or whatever. So things like checking that the spacebar being hit after the game did not change the average, just like I spoke about before. So there we go. So yeah, this is that first error. There were only 9 rounds, so I changed to less than or equals and rechecked, and it was fine. And this is the other thing. I had made an error. I changed the number of rounds to 5, and the average score is calculated with a hard-coded 10 right here. So when I did an average score with 5 rounds, I got a completely incorrect answer. It failed the sanity check. So that's comprehensive boundary checking. And if you've got a few tests like this in amongst all the rest of your tests, bam, that's looking at that excellence. And you may actually have to sort of add something into your program. If you can't find a place in what you've already got to do boundary testing, well, add some code that does force you to do some boundary testing. Be creative about that.